So first, thanks to Loka and Spark Beyond for hosting this and organizing it. I'm Tal Rosenwein, VP of Research and AI in OrCam, at OrCam. Today I'm going to present a new feature that we're about to release soon that aims to empower people with dyslexia and reading difficulties using question answering. So a few words about OrCam before I start. So OrCam was co-founded in 2010 by Amnon Shashua and Ziv Aviram, the co-founders of Mobileye. We are located in Jerusalem. We have 400 employees. At OrCam, we're doing amazing technology that empowers people. Simple as that. We started with the OrCam II to empower the visually impaired and the blind. In the upcoming months, we're about to release the OrCam Hear, which is a hearing aid V2 that helps people with hearing loss. And the feature I will present today is part of the OrCam Learn that helps people with reading difficulties and dyslexia. Yeah. Okay, so in order to support this portfolio of products, my research department consists of 5 research groups, 90 people. So it's a multidisciplinary department, starting from computer vision in the areas of object detection, face recognition, simultaneous localization and mapping. OCR supports 27 languages, ASR supports 10 languages, natural language processing and generation. We research in the area of audio-only and audiovisual based source separation and speech enhancement, text-to-speech, data, and infrastructure. So the title of this slide is End-to-End Question Answering on the OrCam Learn for the benefit of people with reading difficulties. It's a joint work of many departments across the company, starting from software, hardware, software embedded, and algorithms. In what I'm about to show you, there are more than 20 neural net-based models that are running on the background, so I can't elaborate on everything, but you are more than welcome to approach me after this talk. I will be happy to share information. Okay, so let's start with the motivation. So dyslexia affects 15 to 20% of the world's population. It is a language-based learning disability, meaning that dyslexic people have difficulty to translate symbols to spoken language. So at this GIF at the center of the slide, you can have a sense of how dyslexic people experience reading. So as you can see, words are flickering, letters are substituting all the time, which make reading much challenging. And because it's so challenging, dyslexic people usually experience difficulties with other language-related skills, such as word pronunciation, spelling, and reading comprehension. So we would like to improve the comprehension capabilities of people with reading difficulties using a question answering mechanism. So one might ask, why question answering, right? So actually the answer is quite simple. Text is all over the place, right? It's written there, Spark Beyond, Exit Sign, there is text, I don't know. It's all over, right? So we can think of many cases where retrieving data from text is necessary. So let's say I'm waiting on a bus stop and I want to know when the bus will arrive. Or I'm at a restaurant and I see the menu and I want to know what is the price of a pasta dish. Or I want to retrieve the phone number from electricity bill and so on and so forth. Okay, so basically it's something that can help us in our everyday usage. Okay, so they say that a demo worth 1,000 words. So let's see. Just a sec. Just a sec. Okay, so let's think of the following situation. Okay, so let's say I'm a first to third grade till third grade student. Okay, and someone gives me this printed text. Okay, so first I would like to read it and verify that I read it correctly. And then I would like to retrieve some data from the text. So basically the OrCam Learn provides the entire experience, but today I'm going to focus only on the reading comprehension part, the second part. Okay, so this is the OrCam Learn. It's a handheld device. It has a processor, battery, camera, microphone, and speakers to communicate with the speaker. Okay, so basically the usage is quite simple. I just pointed the text and the device will start immediately to read it.
Cheetahs are a type of a large cat. They're the fastest land animal on Earth. Cheetahs live in Africa.
Okay, so after I read the text, now I can start query the device. Hey OrCam, smart reading. Question, what type of an animal is a cheetah?
Cheetahs are a type of a large cat.
Question, who has strong legs?
Couldn't find an answer. Let's try again.
Question, who has strong legs?
Cheetahs are thin. They have powerful legs and small heads.
Okay, so now I think I understood what is written and I want to ask the device to quiz me. Okay?
I didn't understand, but
let's play.
Here is the first question. Where do cheetahs live?
So now the device asks me a question. I can answer. They live in Africa. And the device will verify it.
The answer is Africa. Here is the next question. What is the fastest land animal on Earth?
So it's cheetah.
The answer is cheetahs. Here is the last question. What do cheetahs eat?
Okay, so exit.
Please wait.
Okay, so basically, okay, so let's think together what we've just saw, or what are the modules that we need to build in order to make this thing work, or what could have gone wrong. Okay, okay. So first we need to capture the image, right? So as you can see, the light conditions are not that good, and I need the image to be focused. Okay, next I need to read the text. So I have here the cheetah's picture. I need to ignore it, and more specifically, the dots on the cheetah. So many OCR models will read it as either the letter O or the token period. Then I need to capture the audio and I need to transcribe it. So as you recall, I said the word cheetah, which is a rare word, and the device needs to transcribe my Israeli accent, okay? And last, I need, not least, I need to query the text. So I need a question answering mechanism. And finally, I need to communicate with the device. So I need text to speech played through the speakers to the user. Okay, so what I'm trying to say is that doing textual based only question answering is challenging. Doing it in an end-to-end manner is 10 times harder, okay? Okay. So just a quick recap of what we saw. First, we capture the image, extract the text using an OCR model. Then we ask a question using our own voice, transcribe it using an ASR module, feed both outputs of the OCR and the ASR into a NLP model that returns the answer, and we play it out to the user throughout text-to-speech. So Usually, all of these models run on big servers, right? But here, everything is in here, is embedded. The only thing that runs on cloud is the question answering module, which we're currently thinking whether to deploy it to device or not. We have the technology to do it. Using hard work. Really good with hard work. We write in Neon, assembly, and hard work. Everything end to end is done in OrCam. Yeah, but I can read the text, I can query the, yeah. Except for the, yeah, everything there. But, and we can put the question answering as well here if you want. We just, yeah, I'll talk to you later. No, it's weaker than your iPhone, okay? 10 times weaker than your mobile. Yeah, every printed text. You can do it on the mobile too. If you want to take a photo, you can picture this. No, we are working towards support and written. I'm not sure we need it, but yeah, it's a different topic. Okay, so our algorithms run faster than real time in a streaming fashion. The models should run with low latency, low energy consumption. In order to feed models to device, we need to quantize and prune them. So it's lots of know-how, but at the end, it's really cool that everything runs here embedded. Okay, so let's dive deeper into the model, into the feature itself. So we start with the sensing, we'll start with the OCR. So the goal of the OCR model, so first, sorry, because I want you to go asleep fast. So here's a simplified version of the block diagram of the OCR. In practice is much more complicated. The goal of the OCR module, yeah. We support tabular data, yeah. Okay, so the goal of the OCR module is to extract the text given the input image. Okay, so here's the simplified version of the block diagram. Given the input image, as you can see here, it's one of the Cyrillic languages, newspaper. We first apply the text detector. So the text detector outputs heat map. As you can see here, green blobs is where with high probability, the text detector predicts that there is text. So as you can see, there are some false alarms here on the bottom of the figure. And next step is to, so given the output of the text detector along with the input image, we feed the line detector that predicts bounding boxes over lines of text. And next step is we want to extract the plain text, right? So we feed the output of the line detector to the OCR model and predict the plain text. But this text it doesn't have the right reading order, okay? So a few words about reading order. Reading order is hard, okay? So this is a newspaper. You want to read first the headline, the name of the newspaper and the date, and then the headline, and then the main body from left to right. This is not that hard reading order. Think of Japanese, where you have vertical lines, horizontal lines, some of the lines starting from left to right, the other ones from right to left. It's a really challenging task. Okay, even for human beings, it's a challenging task. Give a Japanese newspaper to a Japanese native speaker, it will take him a while to read a newspaper. It's built that way. Okay, so after we determine the reading order, we now have the plain text. It's right reading order. Okay, so we finished with the OCR module. We'll now pass to the ASR module. So the goal of the ASR module is to extract, given the audio input, extract the transcribed question, okay, speech to text. So here's a simplified version of the block diagram of the SR module. In practice, it's more complicated. So given the audio input, we don't think you'll hear it. So basically it says, what is the name of Beyonce's alter ego? Beyonce, the singer, okay? So we feed the audio input to the acoustic model that predicts the following metrics. So x-axis represents the time, y-axis represents the alphabet, letters from A to Z. Yellow indicates high probability, and blue indicates low probability. Okay, for example, here the model predicts with high probability that the letter W was pronounced as part of the word what. So now we have this matrix and we want to decode the text. So if we apply naive argmax, meaning that on each time step we take the argmax prediction, we'll get the following sentence. Okay, so as you can see here down below, Beyonce and alter ego were misspelled. Okay, so we want to fix it. In order to fix it, what do? We apply beam search. So beam search decoding is a heuristic-based decoding, heuristic-based decoding method. We incorporate into beam search language model that we pre-trained on a large corpus of text. And basically what beam search does is prioritizing candidates according to their language model score. Word. Okay. Yeah. In practice, let's say for now, talk to me afterwards, I'll explain. It's more complicated. Okay, so basically we incorporate into beam search the language model score, and we can say, we can see, because it's okay, so basically alter ego was fixed, but Beyonce isn't fixed. It's because of the zoom. You can see it. Okay, so okay, so we want to fix it. What else can we do in order to fix it? Someone has idea? Any idea? Please help me. We want to fix it. Okay, so basically we know the text that we just read, right? We have the context. So what we do is we train on the fly, on the device itself, during runtime, during inference, we train here a language model, incorporate into beam search, and prioritize according to this model as well. Okay, so everything you saw now on the demo, a language model was built on this text, during inference on this device, embedded, and we can say that both Beyonce and alter ego were fixed. And now we have the transcript question, which is, what is the name of Beyonce's alter ego? Okay, so basically what we have now, we have the context from the OCR, the question from the ASR, and we can move forward to the question answering module. So our models are BERT-like models, and they are fine-tuned. They are fine-tuned on a downstream task of question answering. So basically, what we do, we concatenate. We concatenate the question and the context and feed it to the BERT model that has two outputs, two heads, start and end of span prediction. Each of the heads output is normalized to perform a probability distribution. And so here's an example. Here's the context. Here's the question. You can see it, but the question is, what is the name of Beyonce's alter ego? And we get the two heads, okay? The outputs of the two heads. We cross multiply them to perform this matrix. X-axis represents the start index. Y-axis represents the end index. Okay, yellow indicates high log probability. Blue indicates low log probability. So now we wanted to extract the span, the answer span. So what we do, we take the argmax such that the end index is greater or equal to the start index. So this is how it looks when we look at the log probabilities. But when we look at the unknown probabilities, things are much more clear. Okay, so now we have the span, we map it back to tokens, and we get such a fierce. Okay, but the user, we want to perform a long form answer. Okay, so we have some kind of heuristic that returns a larger context, which is played back to the user throughout a text-to-speech engine, which I will not elaborate, but whoever wants, I can speak for hours about it too. And this is the text that will be played to the user throughout the speakers. Okay, so basically what I showed you today is an end-to-end question answering on OrCam Learn for the benefit of people with reading difficulties. The thing I wanted to highlight is that when you use sensing, when you do it in an end-to-end manner, things are much more complicated, much more challenging, because you have issues with sensing. Okay, so making things work seamlessly is hard, it's challenging, and this is what we do in OrCam.
Why did you decide to do it in a handheld device, embedded, and not go into the maybe first in the internet, online? Most of the learning is done online these days.
Wow, that's a great question. Okay, so basically, it's a good question. Why one? Basically, when you interact with the dyslexic people, usually they also have ADHD, so you don't want them to see screens. And in addition, the goal of, like, we think that this device we're soon about to put it in schools where the phone, they won't put phones like in exams, or so you need a standalone device in order to attract the dyslexic people. Yep.
So now, as I understand, you're working mainly with kids. Is there a plan to work with adults and, for example, produce a summary or a main idea of the text?
Yeah. So basically, we're working towards like high school and students as well in these directions, exactly these directions. Want to ask and I will repeat?
Why does the reading order matter?
Okay, so the question is why reading order matters. Let's see. I'll give you an example, it will be better. Okay, so let's say that the span was if you can see it on the iPhone as well, like reading, they don't do the reading order that well. So basically, if I didn't have reading order, this line was concatenated with this. Okay, and then you could have like things would get really messy. You need some coherent text to be read, and in addition, you want the device also always can read the text to the user, so you must do it in the right way. Yeah.
Is there something, or is there an OrCam system or device for the blind, or for the for vision impaired people? Does it look different? It's like glasses.
Yeah. Okay. I understood the question. Yeah. So the OrCam Eye is for the blind and visually impaired. Basically, we have a mount for glasses. The device itself is smaller. It's like half of this size. And using magnets, you can put it like on, attach to every glass you want, and then you can use it whatever you want.
We're going to have one last question from Zoom, yes, and afterwards you'll have a chance to approach or personally and get answers, okay? So the question is QA BERT a modified version of BERT?
What?
Is QA BERT a modified version of BERT?
Yeah, it's not necessarily BERT is BERT, but yeah, version like encoder. Okay, let's say encoder. BERT is an encoder, so we use encoders.
Thank you.